Here is a particularly difficult limit horizontal asymptote problem from your homework. It's really difficult because this term, obviously it grows infinitely large, but I can't even tell if this term grows infinitely large or not. I mean, this gets really big and this gets really big, but they're subtracted. So does it go to 0 or does it go to infinity or does it go to a fixed number? I have no idea. Also, it's not like it's really obvious what I'm supposed to do here because there's no fractions or nothing that I can combine. So I'm starting to worry, like this is a really hard problem for me. But as I am a person who's done a whole mess of limits problems, I saw that what I had was two terms with radicals in them that were subtracted. And I started thinking, what if I used the conjugate here? What if I used these same two terms, but with a plus sign? So here's what I mean. I'm going to take my limit, and I'm going to multiply the expression by radical x plus 4 plus radical x minus 1 divided by that same thing. So see how this is literally the number 1, so I'm not really changing the problem. I'm not changing the expression at all. But what's going to happen is I can use difference of squares to combine these two and get something cute. And what I get is that the radical signs go away, right? Because radical x plus 4 squared is just x plus 4. So this is what I get. Notice how I copied this hot mess right down here. No big deal. And this part right here is going to simplify really nicely. It simplifies to just the number 5. But I still got to figure out what to do otherwise. So I'm sitting here with limit as x approaches infinity of radical x times the number 5 all over the sum of the two radicals. Okay, so what I'm going to do is I'm thinking, well, I don't like that the x's are on top and bottom, and in a lot of other problems dividing was the trick, so I'm going to try to divide by something and like push this down here. So what I'm trying to say is I am going to multiply on top and bottom by 1 over radical x. The purpose of this is that this radical x should cancel with this, and there will be no more x's on top. I'm not 100% sure what will happen down here, but I have faith that it will be something good. So like I said, you get a 5 on the top, and this is what happens on bottom. The 1 over radical x distributes over these two terms, and I even went further and I multiplied the x plus 4 times 1 over x, like I actually combined those two radicals and combined them by multiplying. So the x plus 4 turns into 1 plus 4 over x, and that x minus 1 turns into 1 plus 1 over x. And now victory is mine, right? Because as x gets really, really big, it's really obvious to me that these two little terms, 4 over x and 1 over x, they grow and grow and grow. Well, they don't grow. The x's grow. And the 4 over x shrinks and shrinks until it doesn't matter anymore. Same with 1 over x. So as x gets infinitely big, this limit turns into 5 over radical 1 plus 0 plus radical 1 minus 0, which is really just 5 over 2. So totally non-obvious from looking at the initial problem that the answer was going to be 5 over 2. But by using conjugates and some fraction tricks, we actually find out that this whole expression literally approaches 2.5 as x goes to infinity.